Hello! Thank you for coming to this live stream today. I really appreciate it. This is the Cardano Aura podcast number 1. So first off, I just want to take a second to say, what is the Cardano Aura podcast? This is Cardano's use and utility podcast. This is for anyone building anything, anyone bringing value to ADA. They can come on here, show how they're bringing value, and just have a nice dialogue about it. My whole goal here is just to have a long-form conversation and give people the ability to show off what they're building with either presentations or just dialogue one-on-one. So the email, if you guys want to be on here, is down below. It's peyton@bloompool.com. Also, if you guys want to support me and my channel, the best way to do so is the Bloom Pool. I have 2 pools, Bloom and Bloom 2. You just delegate to them. We have a 2.5 million pledge to secure the network from Sybil attacks. Another way to support me is also the Brave browser. Downloading the Brave browser blocks ads and pays you in cryptocurrency for doing so. Our first guest today is Sebastien. I'm really excited to have him on, so thank you. And as far as topics,
great to be here.
And as far as topics that we're going to be going over today, we're going to be going over yoroi, a Cardano node built in Rust, also multi-delegation wallets, and a couple other things. So the first thing I wanted to talk about today is yoroi. I actually just saw on Twitter that Ergo support is actually being added to yoroi.
Yeah, and this is actually something that we started earlier this year. So you remember last year, maybe in December or something, we added multi-wallet support, so we could support multiple wallets that are all Cardano.
Yeah.
Right, and this is in the past. If you remember yoroi way back when in 2018 or something, we only supported one wallet, but then we added a multi-wallet UI, and the next logical step was multi-currency, right? And we noticed there's a huge appetite in the community for more cryptocurrencies, but we don't want to be supporting like a bunch of random cryptocurrencies that are supported by all the existing wallets, because then it's not really a unique value to us, right? So we were saying, okay, well, if we want to add a new cryptocurrency, we need to find something that's a unique value for yoroi and a unique value for the Cardano ecosystem. And we thought the most logical project for that was Ergo, because it's created by a lot of people that have worked with us in IHK in the past. It's very similar to Cardano in the sense that they also use UTXO for the way the blockchain works, and they also have a smart contract platform that's powered by UTXO, similar to Cardano. And so it made a lot of sense to have this be the first step for interoperability. Now, Ergo and Cardano have different paths that they're going through, which I think makes them fairly different. For example, the biggest thing is Ergo is proof of work, right? Which means that they can take advantage of some of the research that IHK has done in the past, like NEPA-POW. You might remember NEPA-POW from way back when, which is a paper IHK put out, but it's only for proof of work currencies. But Ergo, because they're proof of work, they could take advantage of that research stream and implement it. So we thought, okay, well, we have Cardano, which is a really solid proof of stake currency, and then now we'll have Ergo, which is what we think is the best proof of work currency, and the support for both of them made a lot of sense. So we started working on adding multi-currency support to yoroi, which involved changing a bunch of things in the code base. And we were on track to getting it done before the Shelley hard fork, and we were hoping to have first Ergo support, then Shelley hard fork. But unfortunately, some stuff came up in my personal life. I had to take some time off, and so we ended up stopping right short of getting it working, and it was so frustrating. But that's why now that you see right after the Shelley hard fork is done, suddenly we have Ergo support coming up. And I've had some people like, "Whoa, how'd you do that so fast?" They're like, "No, we had this like 90% done.
Yeah, already ready to go."
Just like, yeah.
Yeah, my first time seeing that was actually, I downloaded Nightly. It was for Ledger support. I downloaded Nightly, made the Ledger video, and I kind of saw that in the background. I saw Ergo. I was like, what? They're going to add multi-currency support? So I do think that's pretty cool.
So when all that stuff happened, and I knew I wouldn't have time to finish Ergo support, I was like, well, I can't just do nothing, because then people in the Ergo community will be like, what happened? Did they just like never do anything? And I'll tell them like, we're almost there. We have, most of it working. So the best I could do was just enable creating a wallet. You couldn't actually spend any Ergo from it, and it wouldn't sync the balance, but you could at least create the wallet and see your addresses. Mm-hmm. So that I can tell you like, no, look, we had something, but then stuff just came up. But now we're almost done. We have transaction history syncing working. We also have wallet creation working. The last thing you have to do is just transaction sending. But once we have that done, then we'll be ready for V1. There's some features of Ergo that we have it implemented, mostly on the smart contract side. But that's okay. For most people, what they want right now in the Ergo community is just a really solid wallet where they can store their Ergo instead of storing on an exchange. So that's kind of our V1. And then once we have that shipped, then obviously we'll add the smart contract support. Now you might be wondering, how is adding smart contract support for Ergo going to help Cardano? Well, the thing is that to add smart contract support for Ergo, we have to build this like MetaMask-like functionality into yoroi, right? So to have a smooth smart contract experience, you have to be able to go on websites and interact with dApps and so on.
Yeah.
And so we said, okay, well, Ergo already has smart contract functionality, and it works very similar to Cardano. So let's try and think, how could we make this work for Ergo in a way that will also make it easy to add the support for Cardano in the future? And so we had some of our engineers working. Contrary to what people think, it's not just me. We have a team of people. I'm just like the most visible one.
Well, you said you took some time off and it stopped, so I can see why people assume that.
It's because the people who did the work on the back end, they were already done, and they're just waiting for me to finish some of the front end stuff.
Yeah, okay.
So I work on like yoroi, the extension itself. We have other people working on the tooling in the background and servers and so on. And so that's why when I stopped, there's nobody to finish the UI for it and the yoroi itself implementation. But the back end server and all that was already finished.
Yeah.
And so we had some other people on our team write a specification for how they think we should do a MetaMask-like functionality in yoroi. And we published a specification for that, which it's not a complicated specification. It's, we think these are the API endpoints we should provide. And we submitted that to the Ergo improvement proposal repository. And we have some other internal documents about, how we think it'll work. But so that's coming up. And so our next step after we add Ergo support will be adding this kind of smart contract functionality. And then since Goguen IHK is working hard on that, once Goguen releases, then we'll have, not for free, but less amount of work to get that working for Cardano. So we think we'll be in a good position.
Yeah, I mean, that makes a lot of sense, how having it built for another currency would make it easier for as soon as IOHK is done with Goguen. What other features would you like to see yoroi have in the future? A lot of people talk about having a way to notify their delegates through wallets. I know IOHK has talked about adding that. Would that be something that you guys would be willing to add? And also, what other features are you looking for yoroi to have in the future?
Right. So I think for a lot of features, there's split into two categories. One is a feature that we can just go and implement ourselves, and the other one is a feature where we're going to need some sort of new functionality in the node or some agreement for how things are done. And depending on the functionality, some stuff it's easier to implement than others. For example, one of the top features we get requested is support for amounts in other currencies. Like people want to see their balance in USD or euros and so on. That's something that we had also. If you ever looked at the yoroi extension codebase, we have so many features that are 90% complete. It's kind of sad, but that's the reality of the yoroi extension, because oftentimes we're like in the downtime waiting for IHK to finish, Shelly support or finish Jormungandr support or so on. Mm-hmm. And we have like a month or two, and we're like, okay, let's try and get something done in this month or two. And we get 90% of the way there, and then some update comes from IHK. It's like, all right, time to put down pause. But so we have some stuff like what we called it is unit of account. So multiple units of account in yoroi. We had that almost done. So it'd be good to spend like a week, maybe a week and a half to finish that. There's some other stuff that requires a bit more standardization, like this transaction metadata feature, which I think would be really cool. We also recently released a library for being able to create transaction metadata formats.
Yeah, I saw there was like 4 or 5 different formats. I think I saw that earlier.
But we still need to integrate that into the yoroi extension itself. I'd like to propose that as a Catalyst project. So if people watching the podcast don't know, Catalyst is this new thing by IHK where people can propose ideas and then vote on them for treasury funding. So I thought it'd be cool to try and get this feature for transaction metadata implemented in yoroi as a Catalyst project. Because I think it's fairly small in scope. It has a clear use case, clear business value. And so if we're going to propose something, this would be kind of a nice thing to get started and get a good feel for the whole process. But for those who don't know what the business use case is, so imagine you have a store online, right? You want to add ADA payment as an option. Okay. Well, how do you process payments and identify who paid for what? Okay. The easiest thing you do as a store owner is, okay, I have one ADA address. When you buy stuff online, you just send ADA to my address, right? But then it's hard to associate customers with transactions, right? So how do you know customer A bought this item at this time, right? Because they're all coming to the same address.
Yeah, I completely see the issue and where you're coming from on that, because people often donate money through super chats on YouTube, and you can see clearly who they're coming from. And I don't really get any ADA donations, and I think that is because people can't say, "Hey, it's from me," you know. But as far as super chats, I get them all the time, and it's because their name's attached to them, you know. So how would that work? It would just essentially have metadata inside the transaction, and then you'd see that on both sides of the transaction.
So since we're working on this MetaMask-like functionality, right? It'd be great if at the same time we did something, okay, you go on Shopify, some integration, and when you buy something, it pops up the transaction with some fields pre-filled, and one of the fields would be metadata, which contains some unique identifier populated by the website, which identifies, okay, this transaction came from this customer. And I think this would be really useful because if you look at the community, there's this one person that's working on this Shopify integration. And because I think it's a him, doesn't have this kind of transaction metadata, they came up with this weird scheme where it creates like 10 different wallets, each managing like 20 addresses or like some weird thing. He's trying to like juggle all this together. And it's not clean. It's not easy to work with. It's not perfect. It'd be much easier if we can finish this MetaMask functionality and then add this transaction metadata support to yoroi. So I think this is a cool functionality that I think would be useful. We'd like to add. We have some other stuff.
Yeah, like I agree with you completely, man. I'd vote yes on that for sure. I forget what they're called on the Catalyst site. Like there's an applaud on the Catalyst site, the little claps.
Yeah,
I'd do that.
Yeah, I hope to write up the proposal this weekend, and I'll submit that. So if you're interested, you'll probably have the link by Monday.
For sure.
But another idea that's kind of similar is we had this idea of message signing. So something that we've noticed a lot of stake pool operators want is to do giveaways of some sort that people delegate to them. So say like, if you prove that you're delegating to me, I'll do a raffle and give away a t-shirt or something. There's been a lot of stake pools that have tried doing this, but it's always like not perfect, right?
Yeah.
Because there's no good way to prove that you're delegating to a pool, right? So we could use transaction metadata for this. You could say, okay, I'll create a transaction and add a metadata like, hey, this is me, and send it to the blockchain. But why are you sending this transaction to the blockchain? You just want to prove that you own this key. You don't need to make a transaction to do that, right? So we have this proposal. We actually already submitted the specification. If you go to the Emergo Improvement Proposals repository, that says, okay, here's how we think we can do message signing, so that you can prove that you own these certain addresses, you own this balance, you're delegating to a stake pool. And then so the stake pool could have a website that says, okay, enter your message here. And so you open up the yoroi wallet, say like, okay, this is me. You get the message, you post it in the stake pool's website, and you automatically get entered into the lottery. So I think also this would be a cool feature a lot of stake pool operators would like, that we're also half working on. Again, this is something
so how would that process work? How do you sign it?
Right, so you would sign it with the keys itself. Yeah. Right, so if you imagine your wallet, you have a bunch of private keys inside your wallet.
Yeah, for sure.
Usually the private keys are used for signing transactions, but there's no limitation in what they can sign. They can sign arbitrary messages, right? So this is something that's just supported by cryptography. You can sign messages and so on. The complexity that comes with it is, one, how do you group keys together, right? So Cardano is a UTXO-based blockchain, so you don't have just one key in your wallet. If you want to say, oh, I own like this key, this key, this key, this key, or like this address, this address, this address, this address, you need to sign with multiple keys. So you need to group them all together in one file. So it means you have to come up with a file format, and you also need to come up with some extra metadata, like how long is this message valid, who is it intended for. So you have these kind of like meta fields. It's okay, this message is signed for this person, and so on. So the specification for this is quite long, I think. So, but if you're interested, you can go find it on the Emergo Improvement Proposal repository. If you just look that up on GitHub, you'll find it. But it's also something else that we've been kind of half working on for quite a few months.
Mm-hmm.
But it's the kind of thing where we're working on when we don't have something higher priority. But with, this Ergo stuff coming up and the Shelley hard fork and so on, we're always kind of too busy to get it finished.
Yeah. So that's what you'd prefer. Back to the original question that I asked specifically about notifying your delegates. You kind of want there to be a standard made by IOHK before
right.
that would be implemented.
So for that one, sorry, I forgot about that one. So
it's no worries. You just glanced over it.
Yeah, there's a few ways we could do it. One of the ways that's already been proposed is an existing Cardano improvement proposal by, this is by a lot of people. I know Marcus is involved, and there's a few other people involved in creating the proposal. But it's a way to have extended metadata for a pool. Mm-hmm. So as you know, when a stake pool registers on the blockchain, they say, okay, this is my pool name, this is my ticker, and so on. So this is called metadata, pool metadata, right? And so the metadata that you can upload on chain is fairly limited. It's just name, ticker, description, something like that, some small amount of stuff you put in the hash.
Yeah, you just add the extended in there.
Yeah. And so there's a proposal that was originally, Ada Pools kind of kicked it off, and then it was taken up by a few other people that extended it to create something called extended metadata, where you can provide more information like your location, maybe your Twitter handle, and a bunch of other stuff. And one of the things they added in there was an RSS feed, right? And that's part of the extended metadata. So if that specification gets approved and pools implement this, then that means that we could populate this RSS feed inside yoroi next to the pool. So I think if this specification gets accepted, the SIP proposal gets accepted, I feel like this is a decent way to do it. You could talk about security, are these RSS feed messages signed cryptographically, right? Is it really coming from the pool, or the RSS feed gets hacked? So there's some security trade-off to this. But it's an okay first version. The main reason we haven't had this kind of dynamic text in yoroi is just for security purposes. So the way that the yoroi extension works is that it's fully locked down. So unless your domain comes from a specific compile time whitelist, you cannot communicate with that domain. And we do that on purpose to avoid, whenever dependencies gets hacked. So obviously we make sure nothing in yoroi itself gets compromised. But it's very hard in a large project to make sure that your dependencies don't have a vulnerability. So if you think yoroi uses a library that depends on another library, that depends on another library, depends on another library, and realistically, we do our best. We use all the best tooling out there to make sure there's no issue all the way through the stack. But any amount of extra security you can put in is more than welcome.
Yeah. And
so one of the things we do for this is that the entire yoroi extension cannot communicate to any website that is not specifically on a whitelist. And one of the websites we have on the whitelist is, for example, like the yoroi backend, our server that populates the transaction history and so on. But it causes a problem for features like this RSS feed, because it means that yoroi has to go communicate with some arbitrary RSS feed, which is obviously a different URL. So there's ways we've handled this case in the past, but it's not a clean enough from a code perspective, and there's a security trade-off for it. So that's why we haven't had this kind of functionality historically, but it's definitely something that we're interested in.
Yeah. Did you happen to see, because I actually looked at that Cardano improvement proposal about the extended metadata, and to me it sounds awesome, but I think on that same post, Ada Pools actually said that it shouldn't be that way. Do you remember why they said that? Like, why do you think they wouldn't want to add that? What trade-off would there be there to add? I looked at
it like maybe 2 weeks ago, so they might have posted something new since then.
Really?
But I remember the main discussion that we had at the time was whether or not extended metadata should be on-chain or off-chain. And so that might have been what they were talking about. I have to go back and check again. Because the problem with having all the extended metadata off-chain is that there's no way to prove that the extended metadata came from the pool, right? So obviously the pool will set up their extended metadata the first time, but if their server gets hacked, somebody could change the extended metadata to something malicious, right? So how do you modify that? Not just the first time the extended metadata was updated, but every single update after that was really created by the same pool. And the easiest way to do that would be putting it all on chain. But obviously that has some trade-offs because then you're bloating the chain with all this extra information. And so there's some discussion about should it be part of some website? How do you basically host this extended metadata? Should it be part of a website? Should it be on chain? And there's a few back and forths on that topic. And I think the conclusion last time we discussed this was that it would not be held on chain, but instead would be held off chain. But every stake pool would have to create a new key, and they would create a new key that's like an update key, and they would have to sign every update to their extended metadata with their new key. And this is a good trade-off between keeping off-chain to avoid blockchain bloat, but still having some key that is used to prove that you made the update.
So
it
what
could be that
currently
this
is stored on the chain for the regular metadata? Is it just the hash of the metadata file?
Yeah, I have to look it up to make sure I don't say something wrong. But definitely you put the hash of the metadata, because another server like Smash will pull up the full metadata. And then the idea is you run Smash, it pulls the metadata on chain, and then you can compare with the hash to make sure that it was matching correctly. But I'd have to go back and look at the exact binary specification of Cardano to figure out exactly
Yeah, that's no
set of
worries.
things.
Yeah, I was just curious because initially, like day one of stake pool creation, I noticed that the initial hash that I had didn't match the file, and that's why I thought maybe that the blockchain just stored the hash in the domain to look up the metadata file. So I was curious about that. But yeah, it's no worries. The next thing I wanted to go into was specifically another Cardano node, a full node built in Rust, and really you actually made a whiteboard video on that on your channel. So if anyone would like to see a whiteboard, go check out his channel. He does a really good job breaking that down. But what utility do you think that would bring to Cardano? And also tell us a little bit more about the Rust library that you and Emergo are building out.
Yeah, so I can explain that. So first I want to explain some rationale for why we built this. And that is yoroi runs in the browser, right? Which means that all the cryptography, the transaction creation, all that logic has to happen in the browser. This is difficult with Haskell. It's unfortunate, but that's just the reality. Because in Haskell, you have two options. One, you could compile Haskell to JavaScript, which has some known issues and it's not perfect. And option two is you can compile Haskell to WebAssembly, which at the time didn't exist. IBK has been working a lot on Haskell to WebAssembly, and they've made some very good progress. But since it's like a new technology, we couldn't rely on it. So we said, okay, well, we can't have this Haskell code running in the browser. Well, what can we do? Well, Rust is a popular programming language that can easily run in the browser. So it's very easy to compile your Rust code to WebAssembly, which is a language that runs very well in the browser, and it's very fast, much faster than JavaScript. And so because this is a popular language and many companies use this from Rust to WebAssembly and running on the browser, we're very confident that this technology works, and we've used this in yoroi in the past. Like this is how we did the Byron version of yoroi. We had the Byron implementation of Cardano and Rust, and we compiled that to WebAssembly and then had that run in yoroi. So when Shelly came up, we said, okay, well, we have two options. We can try this Haskell to WebAssembly, but we can't be 100% sure it's going to work. And we don't want to take the risk, because if we screw it up, it's going to be, like tens of thousands of people that can't use yoroi, right? Yeah. So we're going to go the safe route. We're going to do Rust to WebAssembly. But to do that, it means that we had to build up, all the Rust functionality equivalent to Haskell. So we basically re-implemented Shelly in Rust. But when I say we re-implemented, I mean we only re-implemented the parts that matter for yoroi, which is stuff like creating transactions or the binary specification of Cardano, how are transactions stored at a binary level and so on. And we implemented all of that in Rust. Now, it's easy to say, well, we have all this in Rust. Why can't we have a full node? right? It seems like a next logical step. The problem is that building the full node it's much harder than you think, because you have to handle the networking layer, which our code doesn't do at all, which is huge because Cardano has a unique networking stack. We didn't reuse a existing library; they rewrote from scratch. That's a huge component. You have to have a storage layer, which is also not easy because it has to be very efficient. Otherwise, it won't keep
Yeah,
up
that's in the
with
browser.
the new
So
blocks on the blockchain. And there's a whole bunch of other stuff that would be missing. So we would like some kind of full node anyways for yoroi, because it's a nice proof that everything is working, right? This, like, how could you prove that your Rust library can support every feature of Cardano? Well, the easiest way is just to sync the entire Cardano chain. If it manages to sync the full chain, then you're supporting everything. You're good to go, right?
yeah,
And so when I was thinking about this, I said, well, wouldn't it make sense to, instead of spending so much time on the networking layer and the storage layer and so on, we instead aimed for a Rust audit node. Okay. And basically what this would do is just like a companion full node to the Haskell code base. And whenever the Haskell code base is syncing blocks, it forwards all the information to the Rust code base, which re-verifies all the information. Okay, and if you do it this way, then you wouldn't have to deal with storage because Haskell's doing the storage. And you wouldn't have to deal with the networking because Haskell's doing the networking. But you still get the proof that your Rust node can handle everything. And you still get the Rust interface that a lot of companies think is useful, because Rust easily compiles to mobile phones, easily compiles to browsers, easily compiles to everything else. And so it'd be a nice way to provide this extra API for anybody that needs to, while skipping on all the quote-unquote hard parts. So that's what the video kind of explains. It goes into more detail about what we supported, what we don't support, and so on. But it would be very nice for us to have this, because when we released this Rust code base that we used to power yoroi, we had a huge amount of companies interested in it. So we have actually quite a few exchanges out there using our library, and quite a few other wallets that support Cardano using our library, because it was just a safer bet and easier to work with than running the full Cardano full node. And so there's clearly a demand for this. And so if we put more work into it, I feel like we could enable even more use cases for various businesses. But the problem is that at Emergo, we already spent a huge amount of money and time on this. But this is not what we're supposed to do as a company, right? We're supposed to, build the dApps of Cardano and so on. And so we're not really meant to do like the core node. Like, we're not supposed to build our own full node, right? That was like clearly that's Irish K's responsibility, right? But despite that, obviously we wanted yoroi to work. We're very happy with our product. And so we said, okay, well, it makes sense for our company to invest in rebuilding all this specific subset of functionality in Rust. But if we want to build this full audit node, that's just outside of the scope of our company. So we're more than happy to have community input. In fact, some companies have contributed. Atomic Wallet contributed some code. And we had somebody else who is an individual contributor also contribute some code to our library. So we're more than happy to have other people contribute. We're more than happy if somebody wants to try and take this on. Like if another company says, oh, I have some Rust developers, I'd be interested in taking on this as a challenge, you're more than welcome to submit a treasury proposal for this and try and build this yourself, add all this missing functionality. But it'd be great if we could have this someday. It's not required, right? If people are happy with yoroi and say, okay, well, it only supports the subset of features you need for a wallet, and that's it. And if the community is happy with that, we don't need to fund this development. But if the company, if the community wants to build this out more into a full audit node, then the community has a choice to fund this.
So what's left? You said that really you could use the Haskell node to verify the networking layer and just kind of keep it in sync, and then it's going to come over and verify. Well, what's left after all the libraries that you guys have already built up in Rust? Like, what would need to be worked on by those people?
So one of the main things that we would need is some sort of way for the Haskell node to pass stuff over to the Rust node. And then that would probably be the hardest part. I don't think it would be super hard, like it's not going to take a year. but it just means you need to come up with some sort of pipeline for forwarding all the information.
Yeah.
The Haskell code base, the way it does its networking layer, it's also through a specification that's online. You can find it, and the specification is also written in a language called CDDL, which is a way to specify binary data. And we already have a tool for taking a CDL specification and automatically creating Rust code from it. So probably what it would look like if a company tried to do this is they would take the Haskell network specification, run our tool to automatically generate Rust code from it, and then try and have the Haskell node forward the blocks in the same format as get accepted on the network. So it'd be considered like an extra peer. And that'd probably be the easiest way to get it working. But I'm sure if you do that, there'd be a bunch of like weird stuff you'll run into, like maybe the specification is missing some functionality or so on.
Yeah.
And that'd probably be what takes the most time. But on top of that, there's another thing, which is that our Rust node doesn't have all the cryptography it needs. So we only have the cryptography for sending transactions and so on. We don't have the KES keys, and we don't have the VRF keys. And that's just because there's no Rust implementation of them available.
Yeah.
And so somebody would have to also add this extra key type to our Rust node to be able to verify any transaction on chain. It would get more complicated if we want this audit node to also run Plutus contracts, because then you have to rewrite Plutus in Rust also, which would be very difficult. But I feel like that's not as important for now. And if somebody wants to add a Rust backend to Plutus, which would be helpful for a variety of things, that could be done as a totally separate thing, right? So, one project would be, okay, can we audit the chain excluding smart contracts in Rust with the schema I just explained? And another project would be, okay, can we write an entire Plutus interpreter in Rust? And both have their uses, and they could both be separate projects if people are interested. And I'm excited to see if anybody in the community wants to help build out this infrastructure.
Yeah, and I think it would definitely be possible, especially as the word gets out there. I was a little bit more curious about rebuilding Plutus and Rust. I know you glanced over it a little bit, but what utility would that add? Just being able to do that from web applications and also mobile, and it being lightweight and efficient.
Yeah, so there's 2 points to it. One is having a language. So if you look at Plutus, the way it works is you have Plutus the language, and then Plutus the language compiles down into Plutus core. Okay, which is like a very simple set of instructions. And the way IHK decided to do it is that, okay, Plutus, the language itself, will just be Haskell. There's no magic whatever. It's just pure Haskell. And the reason they did that way is that way Plutus can reuse all the existing Haskell tooling, right? So if you want some sort of formatting tool or IDE or whatever, it's all already supported because it's just Haskell.
Yeah,
now
I didn't know
we
that.
don't want, yeah, and so this is the way they did it, but we don't want to have to store all of Haskell on the blockchain itself, right? So instead, it was okay. What's the minimum functionality we need to represent a programming language? And so that was announced way back during the Plutus Fest, if you remember that event. They had like Plutus Napkin, which had like a small napkin with like golden rules. And that was like the core set of transformations that'll be hosted by the blockchain itself. And so basically, whenever you have a Haskell smart contract, it will compile down to Plutus core, and that's what will be run on the blockchain. So if we were to try and build a Rust functionality to this, what would it look like? Well, there's 2 options, right? One is you write the core interpreter in Rust, and one is you write Rust smart contracts. Now, if you write the Rust smart contracts, then you need to write, some compiler from Rust to Plutus core, and then you get the benefit of being able to write smart contracts in Rust. You get to reuse all the existing tooling for Rust and compilation of Rust to WebAssembly and so on, which would be useful for notably the off-chain component. So if you remember, for Plutus, every smart contract has two parts to it, as an on-chain component and an off-chain component, right? And the idea for this is whenever you write a dApp, usually you want the on-chain component that handles the actual blockchain, and an off-chain component that handles your actual website, right? You'd put this on your website, and that's how people click on the button and stuff happens, right? So for Plutus, they decided to make them both the same language. And so when you write a Plutus smart contract, it will automatically generate both the on-chain and the off-chain component. So you submit part of it on-chain, you put another part of it on your website, and they work together, right? So because of that, they run into the same problem that I've mentioned about Haskell in the past, where Haskell doesn't run on the browser that well. And so for the off-chain component, they're using JCJS, which is a way to compile Haskell to JavaScript. And again, they're working on this Haskell to WebAssembly. But so if we rewrote the top layer in Rust, then you could write your smart contracts in Rust, take advantage of all the Rust tooling, and then you could also take this Rust, compile it to WebAssembly, embed that into your website, and then that would work hopefully very smooth. And this is not nearly as difficult, probably, as writing the actual Plutus core interpreter in Rust. Because if you want to write the Plutus core interpreter in Rust, then you have to figure out exactly how the Haskell code base works and make sure that byte for byte everything's interpreted the same way. And on top of that, you have to make sure the performance characteristics are the same. Because if you write something where it runs fast on the Haskell implementation, but runs slow on the Rust one, then this is makes it difficult to actually calculate gas, right? So if you imagine a smart contract platform, when someone submits a contract, you want to have a gas cost for the smart contract. How much does it cost to execute it? And how much it costs to execute should depend on how long it takes to run it. But if it takes a different amount of time on Haskell and it doesn't Rust, then it throws everything out of whack, right?
Yeah.
So this part would be more difficult. But the benefit of writing the Plutus core interpreter in Rust would be that it make it easy to embed the interpreter itself into yoroi. So whenever you'd run, you try and do something with a smart contract in yoroi, we could, inside your browser, take the smart contract, compile it down, run it, and tell you what the output would be, all from inside your browser without having to communicate to any external storage, any external server. But as it stands right now, the way that yoroi will have to work is that we'll need to have a smart contract backend, which is a tool that IHK has made. And whenever you interact with a smart contract through yoroi, you'll have to call over to our smart contract backend, which will compile a smart contract and do some calculations and then pass the result back to yoroi. So it won't be able to run it entirely in your browser in offline mode. It'll have to depend on the server, which is unfortunate. But for most users, they don't really care. So it's not that big of a deal. But if you're like a purist and you want everything to run in offline mode on your machine, all inside yoroi, it just wouldn't be possible unless we do this implementation.
Yeah, well, that was really interesting. I appreciate all the insight on that, and I agree with you completely how that would be useful and it being able to all be done in the browser. But it's also nice to know that there's a way to still do it. And I mean, there has to be, how it ties into it transferring over to what IOHK made, where they're running it there. The next thing I wanted to talk about was multi-delegation wallets. You actually made another video on this, and I think you went over like 4 different ways to do it and the pros and cons of each. And I think off the top of my head, your favorite was the third one. And I think that's what IOHK said that we're actually going with, right? Is the third way.
Yeah. So let me do a brief overview of the video for people who may not have seen it. So a lot of people will want the ability to delegate to multiple stake pools from one wallet. Right, so that'd be when you open up your stake delegation tab in yoroi, instead of selecting one pool, you say, okay, I want to delegate 100 ADA to this pool and 200 ADA to this pool and so on. Now, we don't support that yet, not in Daedalus, not in yoroi, not in any wallet, and it's because at the protocol level, this can't be done. So there's kind of 2 ways you could solve this problem. One is solving it at the protocol level, so we could add multi-delegations for the protocol level. Another way is trying to solve it at the wallet level. What can wallets do without requiring a change to the protocol to get this working? Now, the ideal solution, which is number 3, is a protocol level change, because then it's much easier for wallets to implement this. Having yoroi, Adalites, Daedalus, and all the other third parties out there implement this functionality is much easier if it's part of the protocol instead of everyone having to redo the same hack over and over again. And so that was the ideal solution. But the problem is that the IOHK team is obviously very busy. They're working on Goguen, they're working on Voltaire, they're working on Basho, they're working on all this stuff, right? So to say, okay, well, we needed this other new functionality on chain. It's hard to allocate time for that. And so okay, well, what can we do from the wallet layer in the meantime? Because people don't want to wait; they want this, quote unquote, now.
Yeah.
And so in the video, I mentioned the different ways you could do it from the wallet perspective, but they all have some really nasty trade-offs. Like, nothing is like a smooth user experience. You're gonna have to have like a manual and walk people through it and be like, okay, well, if you do this and this happens and this is how it works, and here's a 10-minute video that explains it, which is not ideal. Already with the Udo extension, we have so much stuff to try and explain to users what is going on. Just blockchain is already complex. To have like another layer of complexity just turns people off, right? They want to open their wallets, load in some ADA from an exchange, and delegate, and have it be done. Right?
And then when they click the delegate button to select 5 different pools and then click done, and it just automatically does it exactly.
And so if you're interested in different ways you could do it from the wallet layer, you're more than welcome to check out the video where I go through it in depth. But the way we're most likely to do it for now is multi-account support. And so let's just say right now in yoroi, whenever you type in your recovery phrase, you get a single wallet, right? It's a one-to-one mapping. But it doesn't have to be that way. You could have one-to-many mapping. So you put in your recovery phrase, and then there will be a pop-up saying, okay, which wallet do you want to recover? Wallet 1, wallet 2, wallet 3, wallet 4. And you pick a wallet you want to recover. And each wallet you recover has a different balance and a different set of stake pools you can delegate to. And so this is a way we can solve the problem from a wallet perspective. Doesn't require protocol change. The main user downside to this is that the user has to remember which wallets they're using. So I'm sure we'll get a lot of support tickets being like, hey, I restore my wallet and it's 0. And we'll have to tell them, like, did you create it wallet 1, wallet 2, wallet 3? Do you remember which one you created? And so it has some user trade-offs. But the reason we're going this way is because the users that care the most about this are hardware wallet users. Because if you're using desktop and you want to delegate to 5 different stake pools, it's doable. You can create 5 different recovery phrases, write them all down, and then manage
split up the ADA.
Yeah, but from hard wallets, having multiple different recovery phrases on the same hard wallet, it's super tedious, because every time you have to factory reset your device and enter a new recovery phrase, it's just not great. And so the easiest way to do this would be saying, okay, we'll support one-to-many, not at a delegation level, but at a wallet level. You can have one recovery phrase to multiple wallets, and we'll add that to hardware wallets. That way, instead of having to factory reset your hardware wallet every time, you can, when you connect your hardware wallet, say which hardware wallet do you want to connect to, wallet 1, wallet 2, wallet 3, wallet 4. And so you still have the trade-off where people will have to remember which wallet they created, was it wallet 2 or 3, and so on. But at least it gives them a way to delegate to multiple stake pools if they want to.
Yeah. So
that's what we're working on right now.
From a stake pool operator's perspective, to delegate to a pool, you have a staking public key and a staking secret key, and you generate a certificate to the pool that you want to stake to. You sign it and you submit it. So what would be the protocol level change that would allow you to do that to multiple pools? Would it just be a way to type the amount of ADA within that delegation certificate?
Right, so Jormungandr actually had this functionality. Yodo actually supported this with Jormungandr. We just hid in the UI because Daedalus didn't support at the time, and we didn't want to add a feature that Daedalus didn't support because then it would just confuse everybody.
Yeah,
it'd be terrible if you went to Jormungandr during the Shelly testnet, you create a wallet, you delegate your ADA, and you open in Daedalus, crashes or like gives the wrong result or something. And so we ended up never enabling this feature. But Jormungandr did support multi-delegation. And the way they did it was that they had something called a ratio staking, ratio delegation. And instead of having to specify like 200 ADA to this pool and 100 ADA to this pool, we instead specify a ratio. So you say 10% of my ADA goes to this pool and 20% of my ADA goes to the other pool and so on. And benefit of this approach was that if you add more ADA to your wallet, it automatically gets distributed correctly. And so if we were to add at the protocol level, I think that's the simplest user experience. Because it makes sense at protocol level, it's easy to add more ADA and it automatically works. And when somebody delegates, they pick their pools and it picks the ratio, how much percentage of your ADA you want to delegate. Yeah. The only downside to doing it at a protocol level is it adds another layer of complexity to the calculations. So if you imagine your node has to calculate, okay, who gets how much ADA, and then distribute the rewards. And because this calculation has to be done without slowing down the blockchain, it's done over a long period of time, which is why the stake rewards are so slow to update. Like right now, it's like 4 to 5 epochs, I think, 15 to 20 days. 34? Yeah.
So how do they do that? How do they essentially outsource the processing power over multiple epochs? If that transaction is just in one block, how do they let it be 3 or 4 epochs, or like you said, 5 epochs for that to work?
Yeah, if you look at the specification, different steps in the calculation happen at different times. And so they just split up the calculation over time instead of doing it all at one time. So they say, okay, first we'll compute which stake pools how much ADA, and then next epoch we'll calculate, okay, if this pool has this much ADA, how many blocks could they make? And then the next epoch will calculate, okay, if they made this many blocks, this person will get this much reward. And the next epoch, okay, now we'll calculate their new balance after applying all the changes. So if you look at the specification, it says at which time everything happens.
That's really interesting.
But it just means that the calculation gets more complicated because now you have to handle fractions.
Yeah.
Right. You have to say like, okay, they have 10 ADA, and then 7% goes to this pool and 12% goes to this pool. And then how do you round down and round up and make sure that all the nodes round up and round down the same way?
Yeah, and that's a lot more calculations too. And and also, you should probably, do you think you'd have to have a limit to how many pools per wallet because of all the calculations that come with that, or is that?
That's a good question. I don't know at what point it would become infeasible. I know for Cardano, the mainnet, the way we discourage this is that there's a fee for registering a staking key, which is 2 ADA right now, right? And so if we want to limit somebody, we would not limit them at a protocol level. We would just limit in fees, right? So we'd say something like, okay, if you want to have ratio staking, you can, but every extra pool you add in the ratio costs another 2 ADA or something like that. Okay. So if you want to limit people from doing something, the best way to do it is just limit it at the fee level, because then people will not want to spend, ADA delegating to 100 different stake pools if it costs them 1,000 ADA to do it, right?
Yeah. But that 2 ADA is actually locked up until you undelegate, right?
Yeah. So it wouldn't have to be the same way, because the 2 ADA is not for the stake pool itself; it's for the staking key. But we can come up with a new kind of fee if we want to have this multi-delegation support, because at some point in the protocol we have to stop people from doing some DDoS attack where they have 1 billion wallets, each wallet delegating to 10,000 stake pools, right? Because that would just cause everything to slow down. And the easiest way to slow people down and stop them from doing this is not to stop people from delegating to more than X pools, it's just to make sure that the fees accurately represents the calculation they're imposing on the network.
Yeah, so earlier you talked about blockchain bloat. What does having a lot of bloat inside the blockchain do? I mean, it's obvious that it would probably slow it down, and up to what point could we have information inside of there before it would slow down? And then how much bloat is added when smart contracts come?
Yeah, that's a good question. So if you want an example of bloat, the best example is Ethereum. So if you've ever tried to sync an Ethereum full node, it will take weeks on a modern computer. And the reason why is one, smart contracts that take a lot of computation, and two is the fact that it's all done in something called the accounting model, which is not easy to parallelize across different processes. The smart contract is kind of the hardest part to get rid of, because if you look at the syncing speed of your Ethereum node, like it'll slow down when CryptoKitties came out, because that's when suddenly there's a huge amount of network for people using CryptoKitties. People remember that. But even today, if you would look at the sync speed when the Uniswap token gets released, it would suddenly slow down as it tries to process all these things happening. So smart contracts in Ethereum have shown that they're a big source of bloat. The way we wanted to handle this for Cardano is originally we were thinking of having multiple sidechains for smart contracts. But we've done a lot of research on this topic. We have a lot of papers that IOHK has published that talk about how to do sidechains in Cardano and the trade-offs and so on. But at the end of the day, we thought it made sense to just release some Plutus functionality on the main chain, and then we'll release some stuff on sidechains at a future date. And so if we want, for example, EVM compatibility inside Cardano, that could be done through a sidechain, and then if the sidechain gets bloated, then it doesn't affect the main chain. But it's hard to perfectly solve the problem, because if the chain has a lot of activity, you have to store the activity somehow. Now, obviously, Cardano does a lot of stuff to make things get processed faster. And so in an ideal world, we'll be able to run these smart contracts much faster than the Ethereum can process. But I don't want to give any specific numbers now, because everything that IHK is doing, it's all in lab environments, and it's hard to extrapolate from a lab environment to the real world how it'll actually perform. IHK is fairly confident that everything will run much faster than other blockchains. Mm-hmm. But I can't give specific numbers about how much faster it'll run.
Yeah, that's fair. So essentially, so how do you limit bloat as well? Do you just set essentially protocol limits on what people can store in the blockchain to do that, and then for example, not include the extended metadata on chain? And
right. So sidechains is one way that's somewhat well known, but nobody's really implemented it because it's fairly complicated. The idea of sidechains is you just move stuff off the blockchain. You compute it somewhere else, and then once it's computed, then in the blockchain you just put in the result.
But how do you do that? Is there just some sort of pipeline between blockchains? How do you take something from a certain blockchain and move it to another, and then?
So there's a lot of different ways to do it with different trade-offs. So the most popular way these days, the way that's most interesting, is with zero knowledge proofs, right? So you say you want to do some large computation. You do it in a sidechain, you do the whole computation, whatever, and then you take the proof at the end and you put only the proof on the main chain. And then the people who validate the computation can know that the computation was done accurately, but not know what the computation was.
Yeah, I mean, it's a good name for that, zero knowledge proof.
Yeah.
Because all you really have is a certification.
So, there's a lot of people doing research into this, but the problem with zero knowledge proofs is usually the computational cost is very high, and usually the storage cost is very high. And so you can find a huge amount of different zero knowledge proofs, all implemented in different ways with different trade-offs. This one runs fast, but has high storage, so it has high storage.
So the storage cost on the side chain specifically?
So this would be the size of the proof that you'd upload to the main chain.
Oh, okay.
So for example, some zero knowledge proofs, the proof that the computation was done correctly is in the size of megabytes. So you'd have to dump a megabyte of worth of data to the main chain, right? Which would contribute to blockchain bloat, which is what you're trying to avoid. And so there's a lot of research into different trade-offs for speed and storage, and trying to optimize it. And IHK has been working on this also. IHK has quite a few papers on zero knowledge proofs and so on. But it's still kind of a research field, which is why no blockchain has said, okay, we'll use this algorithm and we'll go with this forever, because every month or two there's a better way that gets released.
Yeah.
So it's
is that like a relatively new thing? Zero knowledge proofs?
I wouldn't call it new, but it's not perfect, and there's huge interest, and so there's a lot of companies kind of cranking out stuff.
Yeah.
So because this solution is kind of in a state of flux, where it's not perfect, and also there's new ways coming out, most people just do a federated approach, right? And so you have a sidechain that's not decentralized; it's run by a federation. So you could say, okay, we have a main chain that's decentralized and a sidechain for smart contracts run by a Mergo plus blah, 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 right? And, people have done this in the past, but people tend to not really like them because they don't like a federated system. They want decentralization.
Yeah.
And so IHK has come up with some ideas to solve this. And they have a paper on the topic called proof of stake sidechains, which is how do you have a sidechain that's operated by a subset of pool operators on mainnet. So the way you would do it is, imagine on the mainnet you have 1,000 stake pools. And imagine we have some sort of stable coin in Cardano, and we say, okay, this will require a huge amount of traffic, so stable coins will use this for daily payments, so we want it to be fast and so on. You'll say, okay, so for this stable coin, we'll have a subset of 10 of the pool operators from the mainnet, and those will operate the sidechain. And then because they're operating both the sidechain and the mainnet, they're already producing blocks on both chains, and they can use this to relay information about the state of both chains to one another. And assuming that more than 50% of the stake pools on mainnet are accurate, if you do a random sampling, then 50% of stake pools on the sidechain will also be honest. And so this was one of the ways that we thought it could be done, to still have a sidechain that can process stuff faster with different set of rules, but still maintain decentralization.
So as a stake pool operator, when Goguen comes out, you're going to have a chance to do that, like you said, is run your stake pool on these side chains. Will you be able to run on multiple side chains at the same time on the same node, or is it going to be different nodes for each side chain? Or
so this is not like something that's set in stone. It's not like we plan to do this and this is how it will work.
Yeah. I'm just curious.
Research for how to do this. Yeah, we have research for how to do this, and we think this seems like probably one of the best ways to go about it. And so we think this is how it'll go in the future. And there's no reason why you wouldn't be able to operate multiple side chains. And Charles has talked about this in the past, also in some of ASMAs. If you've ever heard him talk about stake pools will operate multiple services, they won't just provide blocks on the mainnet. They'll operate multiple services in parallel. This is one of the things he's referring to.
Yeah, right? And so that's why I've heard him say that. And I was just curious if you had to specialize in something, or if you could branch out, like you said.
I don't see how we would stop people from branching out.
Yeah. So would it be a whole different node on the same machine? Or is it like an addition to the node?
If a sidechain has value, it's probably running a different protocol. So it could be a different code base. Yeah. As long as the cryptography can be matched and relayed, that's all that really matters. And that's how you would, for example, have EVM run a different sidechain, right? You'd have a different sidechain which can run Ethereum-style smart contracts, and then some pool operators would opt into that, and they would process Ethereum smart contracts on Cardano, and then post the results back to the main chain.
Okay. Yeah, that's really useful for me. So the final question I wanted to ask you, what are you most excited for with everything coming out? Like, what are you most excited for in the Cardano ecosystem?
That's a good question. There's a lot of stuff. The most exciting thing that we're working on is just our projects with Ergo, because I feel like not only is it great to be working on smart contracts, all the stuff we're doing, the smart contracts we're working on Ergo, will come to Cardano also, because as I mentioned earlier in this video, they're programmed in a similar way. And so not only is it great to get smart contracts out the door and get something shipped that's a product with people using it, it also opens the gateway for interoperability, which is has been one of the main goals of the Cardano project. So we're almost to the point where we'll have the same smart contract running on both blockchains with real users and communication between the two. And we're getting so close that it makes me really excited. We already have stuff deployed on Ergo that's working today that you can actually go use, like Oracle pools. And then so for Ergo, we're just improving that, getting the integration to yoroi working. And as soon as this gets added to Cardano, as soon as we have smart contract on Cardano, then we'll have to open this up to cross-chain compatibility and so on. And after talking about these ideas for a very long time, it's great to see them, finally released.
Yeah, kind of like what you guys are doing with Ergo kind of reminds me of Jormungandr. It's in a different language, but it's just going to be used for Cardano in the future, and you're giving people the ability to actually play around with the tools, and it's cool that you guys can write these dApps before using Ergo, and then to then bring them on Cardano. I think that's awesome.
Yeah, it's a great win-win for everybody involved.
Yeah, for sure. Yeah, the last thing I wanted to do is just answer a few viewer questions, probably for about 5 or 10 minutes, if we can get some good questions. So if you guys have any questions for Sebastian or any questions for me about anything that we talked about today or anything else, feel free. It says there's 87 people here currently, so make sure you guys leave a like. You might not. Do you have it pulled up?
Me? No.
Yeah, I'll just read them to you then. My bad.
All right.
I should have sent you that link prior. Might have a delay.
All right, well, while waiting for people to get in their questions, and something else I thought of that's really exciting coming up is multi-sig. So multi-sig was added to Cardano node like yesterday or 2 days ago.
Really?
And so we're gonna have to work on multi-sig for dayless and yoroi and so on. But it's pretty exciting because multi-sig doesn't add just extra security for individual users. It adds a new class of ADA holders. So a lot of large companies haven't bought ADA, and the reason is because a lot of large companies require multi-sig. They will not hold an asset if they can't have multi-sig because it's just not as safe.
Yeah.
And so once we have multi-sig support, that brings in a whole new category of holders that previously have been unable to hold ADA and brings them into our ecosystem. So I'm pretty excited about that.
Yeah, that is really exciting. Another question that just popped in my mind while you're saying that is what's limiting stake pool operators from using a ledger as their pledge in their pool? Like what's being worked on and what's holding us back from that, if you know that?
Yeah, it's just there's only 24 hours in a day. Is
it just time?
It's just time. We're actively working on it. I actually already signed a new contract with Vacuum Labs to have this functionality to Ledger and probably Trezor also. So it's something they're actively working on, and we'll have that in a future update.
Yeah, and I'm sure a lot of stake pool operators would agree with me. It'd be a lot cooler to have a ledger than cold keys,
Yeah.
Yeah, it didn't look like we got any questions, so we can go ahead and end it here. I really do appreciate you coming on for the first ever Cardano Aura. There's a link in the description down below for people to join the Discord server. I am going to hop in there for probably 10 to 20 minutes afterwards and answer any questions you guys have. But yeah, that was the first episode, so thank you for coming on. Is there anything that you'd like to say before we hop off?
No, thank you for having me. It's been great. Some people might have seen, but Charles did kind of call to action. We said we need more podcasts in the Cardano ecosystem. If anybody wants to have a podcast, we'll help promote it. And then I made a similar tweet saying if anybody wants to have a podcast that's kind of more technical, I'm more than happy to kind of come and help it get started. And so it's great that this is kind of the first instance of a technical podcast that I'm aware of. Hopefully we'll have more in the future. And so I'm really happy to come on here and help you out. If anybody watching this wants to try and start their own podcast to cover a different aspect, there's so much to cover in Cardano. There's no way one podcast can cover everything. So if anybody wants to do a technical podcast on Plutus or a technical podcast on some other aspect of Cardano, and you want me to come on, let me know. I'm more than willing to help people get started.
Yeah, and that's awesome, man. I really do appreciate you coming on and you giving me the chance to pick your brain, because I do want this to be technical, and I just feel like there's a lot of things that were just right over. They weren't right over my head, but I hadn't heard about them before, so it was cool just to pick your brain, ask more questions, and go deeper with them. And this is the first episode, so I'm telling you guys, in 100 episodes, this is going to be awesome. So, thank you.
All right, thank you very much.